So in the last video, we just talked about an example of a combination function where we have a sum or difference of two different functions. So the answers we got there were, let's circle those here. We ended up with x squared plus 3x minus 3 when we add these two functions, and when we subtracted them, we got negative x squared plus x plus 1. Now we want to look at how that changes our domain for each one. So remember, we got m of x here, n of x. We're going to look at the domain for each of those separately, and then look at the domain for the sum and the difference. So we've got, let me minimize this a little bit so you can see more of the screen. So I went to Desmos here, the graphing calculator, and it's nice because especially if I want to keep the same labels for our function notation, Desmos allows me to type in m of x or n of x. I don't need to have f of x for each. So again, we're just talking about domain. We have a linear function and quadratic, so we know that domain for both of those is going to be all real numbers. So we can maybe assume that the domain for the sum or the difference is going to be all reals as well. We want to be careful, depending on what kind of combinations we do, on assuming what those domains are going to be. If we look at the sum, that just gave us another quadratic function. And we should be able to just recognize that from the answer we got. But that's also going to give us a domain of all real numbers. And then the difference gave us another quadratic function. Even though it's flipped, we know that there aren't any limitations here. So we again get a domain of all real numbers for both of these. So we could just say domain, and this could be for either one. We could just say all reals.